Again, welcome to Principles of Epidemiology. In this lectures, we're going to cover the concept of descriptive epidemiology. As we mentioned in chapter 1 of our course textbook, there are two types of epidemiology. That's the descriptive and also analytic or scientific epidemiology. Now, with the descriptive, we are not going to find why there's a relationship between a risk factor and also the outcome or the disease. Also, we are not going to mention if there's any association or to determine if there's any association, but rather we're going to focus on the persons, place, and time. That is the persons involved in the cases, also the geographical location of the cases, and possibly the time it takes. The time mostly will be based on how fast, the goal is how fast the case is spreading among the population in the specific geographical area. And that will be the descriptive. Also, we can generate our hypothesis from descriptive studies or epidemiology. The next, analytic or scientific, this is where we are going to find out if there's any association between the exposure and the outcome, or the risk factor and the outcome or disease. Here we are going to ask a question, for example, why? It's very important. So first we start with the descriptive. Here we say descriptive goal is to monitor the public's health. Also, we are going to evaluate the success of intervention programs and also to generate hypotheses about the causes of disease. So the main goal of a descriptive epidemiology here is to identify and count cases of disease in populations, again, according to the person, place, and time, and also conduct a simple studies. A simple studies here, for example, can be the case report and series, cross-sectional studies, and ecologic studies. We will discuss this in our future lectures. Also, the analytics or scientific epidemiology, the main goal is to compare groups and also systematically determine if there's any association or relationship or even a causation between the exposure and the outcome or the risk factors and disease. So in analytic epidemiology, we can be able to evaluate the hypothesis about the causes of disease, while in descriptive, we generate the hypothesis. In descriptive, we are trying to understand the phenomena or the exposures or the risk factors as it's related to the disease or the outcome. So descriptive generate hypothesis. Then in analytic scientific, we are going to evaluate it. So here also we can evaluate the success of intervention programs. So as we said, the main goal is to compare groups and systematically determine if there's any relationship or association between the exposures and also the outcome. In analytic epidemiology, the couple of study designs can be the clinical trial, experimental study, case control studies, and also cohort study. We shall go through all the study designs in epidemiology in these lectures and more detail in our future lectures. So as we mentioned here, we have the case reports and case series, cross-sectional studies, ecologic studies. This is based on descriptive epidemiology. So our learning objective for these lectures is to describe and also explain the distinguishing features of descriptive studies, including the case report, case series, cross-sectional studies, and ecologic studies. We're also going to describe and also identify types of epidemiologic questions that can be addressed by descriptive studies. We're also going to identify the strength and also limitation of case reports and case series, cross-sectional studies, and also the ecological studies. We're also going to estimate and interpret the measure of association from cross-sectional studies, and also explain the concept of ecologic fallacy. So we shall go through the concept of ecologic studies and what ecologic fallacy means. So first we start with a case report and also case series. This is the simplest descriptive studies. Now with a case report, detailed report on one patient, usually new or unusual symptom or problem. So normally if there's a new case, an unusual case or a very rare case of only one patient, then we can again use the case report study. And we'll give examples soon. Now, if we have more than one patient or a group, example, detailed report on a group of patients with the same symptom or problem, usually new or unusual problem, is what we call the case series. So case report and case series is almost the same concept. The only thing is that with case report, we have only one patient. And most of the time, the cases will be a new or unusual case. With case series, we have group of patients with the same symptom or the same problem. And also it's a new case or unusual case. Example will be in 1981 when HIV/AIDS was discovered. And we will see the example soon. So with the case report and case series, it's useful for recognition and description of new cases. I think that's the most important. It's a new cases and also new manifestation of old diseases. So with case report, case series, here we don't understand the problem or the cases. So the goal here is again, trying to understand the phenomena, how the case is. Also detection of new or detection of drug side effects. I'll say a new drug side effects. Also provide insight into disease mechanisms and also provide information that help develop hypotheses. So this is again the main goals of a descriptive studies. Now, example is given. This was 1981 case series. Example of HIV/AIDS research. The earliest information about what now known as HIV/AIDS was learned from case studies and also a case series of patients in 1981. There was a common characteristics of these patients where they were all male, young, otherwise healthy, and homosexual. So here there was a stimulated hypothesis that the mischievous disease, which in this case HIV/AIDS, were somehow transmitted through homosexual contact. And this case series was again done in San Francisco, 1981, when there's a couple of middle men, young, very strong, active, having a disease that is normally common among very old people, highly pneumonia disease. So we see a case report again is a detailed report on one patient, usually again new or unusual symptoms or problem. Then case series again, detailed report on a group of patients with same symptom or problem, usually to be a new again or unusual cases. Now we have a main limitation with case report and case series. There's no explicit comparison group. No explicit comparison group. So next we go to the ecological studies. Ecological studies is a study also that examines the rate of disease in relation to a population level factor. Now the difference between ecological case study and case series is that with the ecological, the unit of observation is group. So it can be a one community. Example here, give you the whole country, state, or neighborhood. For example, we can come to a point that people from a specific region contact HIV or AIDS more often than people from different regions. So this will be, we are measuring the observation based on the group, a specific location, or a country, we can say. But with case study or case series, the unit of observation is individual. But the goal of ecological study also is the same. We are trying to understand the phenomena, the person, place, and time. So with ecological studies, we say the underlying question can be, example, do smokers have higher death rate from coronary heart disease than non-smokers? So we can see this question is not individual, it's a group of smokers. It's relating to smokers in general. So exposure can be an individual cigarette smoking habit. Then the outcome will be individual death due to coronary heart disease. Now, with the ecological studies, we can also say, do US states with higher smoking rate have higher death rate from coronary heart disease than states with lower smoking rates? So we can see, again, ecological studies based on grouping. Here we want to see in a specific region, if the smoking is very high, the chance of coronary heart disease or CHD will also be very high. So the exposure will be per capita average cigarette sales in each state. And then the outcome will be a coronary heart disease mortality rate in each state. So our goal here is to find out if there's a relationship between per capita average cigarette smoking. So we are talking about average, the whole group, the whole state, average smoking. If state consume more cigarettes, then that state may have more patients with, again, coronary heart disease, or the coronary heart disease mortality rate will be very high if cigarette consumption is high. So we have something we call the ecological fallacy or the bias. So the whole concept of ecological fallacies, since we said ecological studies, our unit of observation is grouping, we cannot say that, okay, people from one specific region, due to this factor, they are more prompt to this type of cases. Maybe we may have people from the same region, they are not prompt to that very case. So we may have a bias there, not everybody, not the whole group that it can, again. So that's the concept of ecological fallacy. So for example, we say exposure is measured as average for a population, not a person, not individuals, average of the whole population. So there's no real link between exposure and disease. But our interest is in the individual level effects. So a strong association was seen in the prior examples, but are we certain that people who smoke were the ones who died from coronary heart disease? It depends. There are some people who may smoke, but they may not have this disease. And there may be some people who don't smoke, but they may have coronary heart disease. So this is the concept of again, ecological fallacy. We did a studies in the US, look all the states, all the 50 states we have, and we find the average cigarette consumption in each state. Our goal is to determine if average consumption of cigarettes for a state is high, will coronary heart disease also be high in that state? Now, this is average. We are not dealing with individual, we are dealing with the whole population in each state. So it may depend. Ecological fallacy may, or a bias may happen. So here we said, can we use the previous data to fill in the cells of 2 by 2 table? Now, ecological fallacy means that the group level association may not transfer to individual level. So we may get example here. So the example here said, an ecological study of ethnicity and HIV prevalence found that American nations with higher proportions of immigrants from Africa, Asia, and Europe also had higher prevalence of HIV. This may be correct, but most likely if we compare to individual level instead of using the average population data, We may have some individuals that, again, may come from these regions, but they don't have a chance of them having HIV or AIDS is very low, comparing to even some other people from different regions. So this other limitation of ecological study, as we say here, usually can't adjust for confounding factors. We cannot adjust for confounding factors. Again, we're going to cover the concept of confounding factors in our future lectures. But the concept of confounding factors in general is a variable that can create an association between two outcomes. So without that variable, maybe there will be no association between those two outcomes. Sometimes we use the term the log variables. So a very simple example, let's say there's an association between ice cream sales in Florida and also shark attack in Florida, because data shows that in the summer weather, when the weather is very warm in Florida, ice cream sales goes up. At the same time, shark attack in the oceans also goes up because the water is very warm. Now we can see there's an association, increasing association. Ice cream sales goes up, shark attack also goes up. But that doesn't mean that when a person either buy ice cream and it goes to the ocean, he will be attacked by shark. Or when a shark attack a person, the first thing we do is to go and buy ice cream. No. So we have a third variable, which is the concept of confounding factors. In this case, it will be the weather. When the weather is very warm, it creates these two relationships. Here also we said, could the association between cigarette sales and heart disease be due to another factor, which is possible? Maybe some states have a high cigarette consumption and also heart disease. Why? Because that state, they also don't practice maybe physical activities, and their economic status is very low. We have some poor state and rich states in US. So because of that, they don't take good care of their health. They don't have no good health insurance. So all these factors can contribute to, again, heart disease, not only the cigarette smoking. So we may go to a rich state where there's a lot of, the cigarette consumption is high, but this population are very rich. They have a good healthcare program. They have physical activities. They eat a very good nutrition, practicing, etc. So most likely heart disease rate will be low. So that's the concept of, again, confounding factors. So what factors might be confounders between cigarette smoking or high cigarette sales and heart disease? To my experience, I would say physical activities, good medical insurance, and good nutrition. All this can be a confounders factors between these two relationships, cigarette smoking and heart disease. So this is a complex relationship, can be masked here. Now, what is the strength of ecological studies? First, very cheap, inexpensive, and very fast. Also conducted on available data. It's very good for earlier stage of knowledge, same as a case studies and case report also. Also wider range of exposures, especially for international studies, than other types of studies. Also may wish to study ecological relationship, for example, the effect of motorcycle helmet loss on motorcycle fatalities in a state. Our analysis is easy using correlation coefficient or linear regression. Now, next we move to the cross-sectional studies and also survey. So here the definition said a study or a survey that examines the relationship between an exposure and disease at a single point in time. So doing cross-sectional studies, we are going to collect our data at a very particular point of time. There will be no interval to study the relationship between the exposure and outcome. And this will come to when we are doing, again, analytic epidemiology studies, such as cohort, case control, etc. So sometimes the cross-sectional study, we also call it prevalence studies, because the main goal is to find the prevalence. It's based on the population, or we say proportion. An example of finding the prevalence, we say how many cases we have and what is the total population. Let's say we have 100 cases. The total population in that geographical area is 1,000. So the prevalence will be 100 divided by 1,000. And that's the main goal of a cross-sectional studies. The goal is to take a snapshot. So we take our data, measure it. Also measure the exposure prevalence in relation to disease prevalence. Many government surveys are cross-sectional. So example for cross-sectional studies or prevalence studies, we are doing the HIV/AIDS research, a study of injection drug users in Madrid, Spain. This study was done in 1996, and the goal is to find the risk factors for self-reported HIV seropositivity, included passing and taking use syringes, inconsistent condom use with different types of partners, or variety of types of drugs used, history of incarceration. The goal of again, cross-national study is that we take a data, and these are the questions we ask our participants at a particular point. So based on the data, we came to conclusion that most people who have the HIV/AIDS practice this, for example, passing and taking used syringes, they're sharing syringes. Also, they don't use condom or safety regularly, or they have a history of incarceration. So this is a cross-sectional survey of coronary heart disease among farm owners by occupational physical activity. So for example, here we have not physically active and physically active. So in our case, the exposure will be physically active. Non-exposed means not physically active. Now we collected data and we found out that number of CHD or coronary heart disease is 14 for those who are not physically active, and also 3 for those who are physically active. So we can see just the first two, that physical activity, again, plays a major role in the number of CHD. Now, the number that were examined were 89. And out of 89, 14 have the problem. And those who are physically active, the number of exam was 90, and only 3 have CHD. So here we can find the prevalence of CHD at the time of survey. The prevalence for not physically active will be 14 by 89. Then physically active will be 3 by 90. So we can see that the prevalence will be very low, very small with the physical active, and not physically active will be very high. So to find the prevalence ratio, then it will be 157. Here we can use 14 by 89 divided by 33 by 1,000, but we are using, divided by, if we use 14 by 89, we will divide by 3 by 90. Here we are measuring 1,000 per population. So 14 by 89 is the same as saying 157 by 1,000. We want to measure it in 1,000 rate. So to find the prevalence ratio, it will be those who are not physically active, the prevalence of not physically active by the prevalence of physically active. And this gave us 4.75. So this tells us that the farm owners who are not physically active have 4.75 times the prevalence of CHD as farmers owners who are active, physically active. So this data may tell us that if you are not physically active, you have 4.7 times chance more to have CHD than those who are physically active. So that's the whole concept today. This is a cross-sectional studies. And one of the advantage we will see right now is very quick and very cheap. We took the data at a particular point of time. So we have, again, 89 people were examined. Those who are not physically active, 89. And also physically active, we are examining 90. 3 have the CHD problem, 14 have the CHD problem with not physically active. So in this case, we can find the prevalence ratio, which will be the prevalence for not physically active divided by prevalence of physically active. And that gave us 4.75. So if you are not physically active, you have 4.75 times more chance that you may have CHD comparing to the farmers who are physically active. So that's a limitation of cross-sectional studies. Again, the key word is time, temporal. Since the data is collected at a specific time, we cannot study the relationship between exposure and the outcome or the risk factors in the disease. We cannot, because it's a particular term. So here we say problem inferring temporal sequence of exposure and outcome. Which came first? Now, disadvantages is cannot establish causality because we cannot prove exposure comes before outcome in time, because our data is collected at particular time. We don't know when the exposure and the outcome. Also inefficient for real outcomes, very new diseases. Now, cross-sectional studies are problematic when exposure is challengeable characteristics. Example, smoking is very difficult to find a relationship with the outcome. We need time. Drinking, physical activities, or we need time to find out there's a relationship between smoking, drinking activities with any disease. But they are okay for immutable characteristics. For example, genetic traits, broad type. Broad type is the same always. So as we take a data at a point in time, comparing a genetic traits of broad type with a disease, we can get accurate results. Also, measures of long-term exposure. For example, here we have a lead in the bones, or we have historical exposure. Example, the activity level over the past 30 years. Now, the strength of cross-sectional study also is relatively quick and inexpensive. Again, all the descriptive studies, study designs are very quick and inexpensive comparing to analytical or scientific epidemiology studies designs. They are also highly generalizable if based on general population. Also, problem with temporal inference can be avoided for inalterable or long-term and also historical exposures. So in summary, these are the descriptive studies we went through: case report or case studies, and so case report or case series, ecological studies or cross-sectional studies. Sometimes we may use the term also case report study. So sometimes you say case. In general, when I want to use case report or case series, I may say case studies, ecological study, cross-sectional studies. Now, we have the definitions. As we said, with the case report or case series, it's a report on one or more patients with the same symptom or problem, usually new or unusual. Now, the strength is very simple, inexpensive. Also provide variable insight. This would give us the phenomena we want to learn. Mostly is very advantage for new cases. Also, there's no any explicit comparison group. With ecological study also, the study that examines rate of disease in relation to population level. So based on grouping, but the same concept as case report or case series or case studies. we can see the advantage is the same, very simple, fast, inexpensive. And also limitation is almost the same, no information on individuals. It's a group level association. Also may not translate to individual level. This is where we have the ecological fallacy. Now with cross-sectional study, it's a snapshot. The reason why we use the term snapshot, because with cross-sectional study, we take the data at a very particular point of time. We don't study the exposure and outcome within an interval or some period of time, no. So study, examine exposure disease relationship at the same single time point. Very fast and expensive. But when it comes to the time period or its unclear temporal relationship, if exposure is changeable, we may have exposures that can be changed. We don't know what effect it will have in the outcome. So cross-sectional study is not good for that. It's good for immutable programs that or exposures that doesn't change. So that will be the conclusion of our lectures here. Again, these lectures will focus on the concept of, again, descriptive epidemiology study design. And here we mention 3 types of study designs, which is, again, case studies, which is case series and case report. Then the second is ecological studies, and then the cross-sectional studies. So in our next lectures, we will move on to analytic or scientific epidemiology study design, which we will discuss the case control. We also will talk about cohort studies, and we may talk also about experimental studies. So again, wish everybody the best. If you have any question, feel free to send an email or post your question in the Blackboard discussion. So that's it. Thank you very much for your time.